spreads up to 78 different samples. You'll hear about it tomorrow from Paul Mahaffey, the principal investigator with his team across the world, to look at the full isotopic spectrum of the building blocks of life: carbon, hydrogen, oxygen, nitrogen, many other features. It can sniff the atmosphere for methane. It'll start to get us to the surface of Mars the way we were looking at moon rocks 40 years ago. You've all heard, I'm sure, the great stuff from the 40th anniversary of Apollo 11. What did we learn? Well, we learned how old the planets are. We learned how they put themselves together, where they may have come from in the case of the moon. Well, this is moving that kind of laboratory gear we all had in labs across the world in 1969 and 70 to the surface of Mars. That's pretty cool. So MSL, lots been said. Is it too big, too hard, too expensive? That's for all of you and the public to decide. It is the most powerful field robotics laboratory system in the history of humanity. We're sending it to Mars because that's the right place to start the quest for the chemical building blocks of life on another planet. Now, the rest of the universe is wide open too, and our astronomers will talk about that. So MSL is really like the Hubble Space Telescope does Mars, with 78 samples that it can run and another millions it can process through its other analysis capabilities. By the way, the imaging system on here too, built by Malin Space Science Systems, was inspired by the cinematography of James Cameron. So we're going to go from imaging where we see sort of 20/20 to imaging with telephoto lenses and a descent imager that will take a movie of the full descent as we come down. Pretty powerful stuff. So get set, folks. MSL will reach Mars. Now, the next great steps in Mars exploration will include atmospheric experiments and also something that we've been thinking about since 1976. And I know the deadly three letters I must mention to all of you. It's the road to human exploration. It's Mars sample return. And a lot's been said about that. This is one of the concepts we've been working on at JPL and across NASA for almost the last 7 years, which is to use the SkyCrane technology to land as 3 separate systems the building blocks of returning materials from Mars safely to Earth for analysis here, where billions of dollars of labs would be ready to collect the materials discovered and brought back. And this is a mission that really couples geology with astrobiology. How we search for life on a planet in the records, in the rocks, in the soils, in the frozen stuff. So here you see one concept for the Mars sample return mission lander. It includes, as part of that lander, not only a little fetch rover, this cute little thing you'll see here, these are the solar panels, but it would also include a Mars ascent vehicle, or a rocket, that will return those samples to Mars orbit for return to Earth. This is the mission of our dreams. And the 500 grams to kilogram of stuff we would return from Mars is the confidence that would allow concepts like this, and this is purely a notional one, for human beings to go to Mars. So the science we're doing now is science in its own right, it's exploration, and it's also the gateway to the things many of you are interested in. Whether we can get off planet and land on another world, a world that's not Earth, never was Earth, probably never will be, that can tell us about ourselves. And this kind of exploration, these women and men in this movie, certainly not real, folks, so please watch the movie, is just one concept for how humans could go to Mars. NASA just finished a 2-year study. The report's out. The editor's Brett Drake from Johnson Space Center on another design reference mission for humans to Mars, circa the 2030s. The date is subject to whatever. But the real point is that eventually we'll have to make that leap. It's a choice to be made by the peoples of the world. For science, for exploration, for technology, for motivation, for curiosity, for inspiration, all those great things. It'll be an investment in our nations and the peoples of the world's future. There was a great program done in Canada for Discovery Channel Canada to show what that might look like. These are just some of the options that many of you studied, that we've all studied literally for the last 25 years of putting humans on Mars. But you might ask, is it really worth it? The robots can do so much, and they can, and they have, and they must for the next several decades perhaps. But eventually, going there ourselves, exploring as humans do, adapting to that environment is something that's very special. Joe Levine and I led a study of some 30 scientists from around the world on what the science goals of having people there would be. Could we do all of that with robots? Maybe over time, the answer is yes. Perhaps. The answer is yes. However, making the kind of discoveries, and of course this looks like, anyway, it looks like something out of a shopping mall, but it's just an analogy for what we can do. Humans someday, I believe, scientifically, must go to Mars as experiments in their own right, but also to allow us to really interrogate the Mars system for those really elusive clues to how this planet worked. We found that works here on Earth. I'm going to show you in a minute how it works. Now, one of the building blocks, and I'm just about done, that is going to be needed to eventually enable human exploration and even sample return of Mars with robots is new classes of vehicles. These are being debated now by the Augustine Commission, rightfully so. One of the ones that would be most enabling, and this recurringly returns to our mind as we think about going to Mars, is the kind of heavy lift launch vehicle that's now on the drawing boards at Marshall Space Flight Center known as Ares 5. Putting hundreds of metric tons into low Earth orbit is the enabling step, the same way the Transcontinental Railroad got us to California and the 707 flew us to watch the Dodgers in Los Angeles. Being funny there, but sorry about that. It is morning. Anyway, those kind of vehicles and the information technology and the science planning tools and the next generation of kids that will be doing that are necessary ingredients to opening the Mars frontier. They really are, folks. There is no getting around it. There is no easy path to space without going to space. Since we live in space, it's natural. So the shuttle has given us a generation of one way of acting. Larger vehicles like the one I just showed is another. So let me finish in my last 5 minutes with a couple of thoughts. One of the best ways to get to know Mars, of course, is through our robotic missions that we're flying now. The Mars Reconnaissance Orbiter, the Mars Exploration Rovers, what was known as Mars Global Surveyor, Odyssey, the European Mars Express mission, upcoming missions known as MAVEN, for example, being built right here in Maryland. And, of course, the Mars Science Lab. The other way is to go to the Mars analogs on Earth and understand them as if we were on Mars. One of my favorites in particular was one named by 2 Air Force pilots in 1962, Don Juan's Pond, right here seen from the eyes of the IKONOS satellite in the dry valleys of Antarctica. This area, about a kilometer by a half a kilometer wide, is the coldest wet place on Earth. The hypersaline waters in this mud-like pond actually contain cyanobacteria. Whether they were blown in or they come from the discharge system that feeds that pond, here you see us watching it during the International Polar Year from IKONOS and GEOI, is unclear. But this kind of environment on Earth is rare. It may be so rare that it better embodies some of the things on Mars. The average surface temperature here is minus 22 Celsius. Of course, the surface pressure is Earth atmospheric. Pressure at the surface of 1 atmosphere. But however you look at it, it is a harbinger of what's to come. This is the salty terrain seen from a helicopter, where inside some of these salt deposits we find halophytic and cryo types of organisms. This is the pond when it's rarely wet. These are the kind of environments on Earth that scientists today go to with the kind of equipment that we can send on robots to Mars. This is when it's dried up. You can see a field team here. This is actually an ecologically protected site. We have found deposits like this through the Odyssey Themis instrument on Mars. Salt-rich deposits that could be, in fact, and this shows it up close, could be the kinds of things that we need to recognize as possible ancient habitats. And so the fact that we found these kind of environments, not wet today on the surface, on Mars is, I think, a beacon for us as we think about the planet. So going to Mars today is very exciting. The other thing we do is we go to places where we can fully explore with humans as if we were going to Mars. One of those places is the recurring field trips, and one coming up you'll hear about tomorrow, to Svalbard on the Norwegian island of Spitsbergen, where we take some of our field astrobiology gear from across the agency to places that contain these otherworldly signatures of things. And so a team of scientists are leaving later in the week. This is the Mars meteorite. Okay, we look for things like that. Some of the PAHs and other signatures we find we now can actually study in the field. Of course, this is not a robot. These are people. Notice the Macintosh computer. Anyway, not sure they're space rated yet, but they're getting there, I'm sure. But this is the kind of practice we now have in our field analog programs. So let me finish with just a thought. I've been looking for Mars on Earth my whole career. It spans now 30 years, I'm embarrassed to say. I guess my gray hair reflects that. One of the places I've been most mystified by are the new lands on Earth that form after volcanic eruptions. This is the biggest one that formed in the last 50 years, the island of Surtsey, off the coast of Iceland. It's the mid-ocean ridge coming on land. Of course, we don't have things like this on Mars. But here, gully systems shown on CERT-C, which are identical to those that we've now discussed.